Hello everyone, my topic is geodetic imaging of shadow creep along the Xianshuihe fault and its frictional properties. The Xianshuihe fault is an active fault in East Tibet. Historic seismic activities on this fault are very frequent. In the past 300 years, there have been 8 earthquakes of magnitude 7 or higher. Geological and geodetic steep rate of the fault is 7 to 15.5 mm per year. Whether the fault exhibits shadow creep is controversial. We use the Sentinel-1 data to obtain the deformation field of the Xianshuihe fault. All the data was acquired between November and February in 2014 to 2019. Interferograms were generated using LinkSAR. The time series method we used was sparse in steps. We also reduced the atmospheric error using geckos. Here are the obtained ascending and descending light outside velocities. The positive values indicate motion towards the satellite. Both light outside maps show very sharp gradient along most of the Xianshuihe fault, providing evidence for shallow seismic slip. Then we retrieved the fault parallel and vertical velocities, combining ascending and descending light outside velocities. The velocity gradient is more evident from the fault parallel velocities. The vertical velocities show no obvious change across most of the Xianshuihe fault, suggesting that the vertical motion is small. In order to obtain the along-streak variation of shallow seismic slip, we plotted a series of short swarth profiles, 10 km wide and extending 4 km either side of the fault. We fitted a straight line across either side of the fault. The result shows that the surface creep is widely distributed along the entire fault. Shadow creep rate of the western part is lower than that of other parts. We use the simple screw dislocation model to invert kinematic parameters based on fault parallel velocities. The velocity contains two signals, the inter-seismic tectonic loading and the shadow seismic slip. We plotted 10 profiles, 100 km long and 20 km wide, and obtained the bed feeding curve and parameters of each profile. Our result shows that the tectonic loading rate gradually increases southeastward along the Xianshuihe fault, with ranging from 8.8 to 17.9 mm per year. Shadow creep is widely distributed along the entire fault above a depth of 6 km. Shadow creep rate on the western Salaha branch is 6.3 to 19.8 mm per year, higher than the tectonic loading rate, indicating that the seismic is after-slip following the 2014 Guangdong earthquakes. Combining our time series surface slip and documented transliteration series, we calculated A minus B on DOF and Guangdong segments in the framework of rate and state fraction. The result shows that the DOF segment has a higher A minus B than Guangdong segment, which is potentially to be caused by changes in rocky types along the Xianshuihe fault. That's all. Thank you for your listening.